a common mistake. So I have in my mind, I want to do a y versus x table, and that's the problem. That leads to a mistake. So I'm going to put my y data in the first column, my x data in the second column. I'm just going to remind myself and you that this is the independent variable and this is the dependent variable. So that's not really part of the data table, that's more of the teaching right now. And I'm going to list, create a title for my table. Not a title, a heading for the column of the table. So my independent variable is going to be displacement, measured in centimeters. And somebody has their microphone on. If you can turn it off, please. The dependent is going to be time. And I'm just going to make a bunch of numbers up here. Let's make this a little smaller by going up here. With Google Meet and everything running, it's taxing the computer, so things are a little slow. So I'm sure you've noticed that. That's just part of life right now. I don't know what happened there. Looks like I didn't press tab when I did the time part. So move that here. That was just a copy and paste. Okay, so time, I'm going to have 0, 1, 2, 3, 4. Now, I'm going to go up to 10 seconds, and I can keep typing. But one thing I can do is I can take advantage of Excel recognizing patterns. So I'm just going to highlight this, and that's a series of numbers, 1 through 4. And Excel can figure that out if I highlight it. So I'm going to take this little square down here, and I'm going to grab it, and I'm going to pull it down. And what that does is it continues the series. So imagine if you had to create a series of like 1 through 100, that would be very tedious. But if you just type 1, 2, 3, grab that, and then you can just pull it down like a window shade. Now displacement, I'm making up this data, okay? And what I'm going to do is I'm going to do it by twos, 2, 4, 6, 8. And the same thing, I'm going to highlight this, and Excel recognizes that there's a series there. And Google Sheets does the same thing, by the way. Grab that little square in the bottom right-hand corner, pull that down, and then that fills everything for me. Okay, just going to make this a little smaller. And now what I want to do is I want to format the table. So I'm going to highlight everything that I want in the table, and I'm just going to make it really simple. I'm just going to put lines, borders, and I'm going to do all borders. If I want, I can make stuff bold and stuff, but you guys can figure that out if you choose to do that. What's important is I have the headers above each of the columns, and then the data. And in the headers, I also have the units. Don't forget that. So now the next step is I want to insert, that's the term, insert a graph. So I'll go into the insert tab right here. Now, Excel uses the term charts. We call them graphs, but they call them charts for some reason. I don't know why. That's not really important. But what is important that you select the correct chart. And in science, it looks like we do line graphs, but we don't do line graphs. We do scatter plots, okay? And we insert trend lines into our scatter plots. We never do a line graph, because a line graph just connects all the dots. That's something that you may be doing in business if you want to look at certain trends. It's a very different type of graphing. So I'm going to go over here where it says scatter plot. I'll click, and we got a pull down menu, and these are all the different choices. And it's the first one, the one that just is going to do a plot of the scattered dots. That's why it's called a scatter plot. So click that. No, that didn't work because I forgot to do something. So here, oops, highlight that. Okay, you're allowed to laugh, that's fine. Highlight the table first because I want to scatter plot the table. And now go to insert and scatter, and then click that. And what it'll do is it'll create a scatter plot, exactly what I want. So it's going to move this up a little bit. Okay. And now I'm going to evaluate what I just did to make sure I did it correctly. Now, where is the time? On what axis? Is it on the y-axis or the x-axis? You can figure that out by looking at the high numbers, 20 and 10. So I screwed up, and I told you I would. Okay, what I did here is I put the wrong information in the A column. So if you want to create a scatter plot, the easiest way, you want to first have the dependent variable in the first column, the dependent variable followed by the independent variable. So what I'm going to do is I'm just going to get rid of the graph because I'm going to redo it. So I highlighted it and pressed delete. Now I'm going to go to column A and I'm going to insert a column. Now where do I do that? The problem is I need to go all the way up. The video doesn't capture this. I didn't think of that. So I go to the top of the page to the overall Excel menu, and I go into do the pull down menu. As you can see, the bottom half, and it says columns. So I just inserted a column there. And then what I'll do is I'll highlight column C. I'll copy it, Command C, and then I'll go to A and I'll paste it. So that's the quick way of correcting it. And then I'll just delete the redundant column. And then I'll redo everything. Oop, that's not what I meant. I meant to go to the edit, and then I want to clear all, because that'll also clear the borders. There you go, that's better. Okay, so if you actually end up looking at this video for review, you can pause, of course, and look at what I'm doing and repeat. That's the beauty of teaching through video. Okay, so I have my data table highlighted, and I'm going to go insert the scatter plot, and there I have it. And I'm going to double check. I want to make sure that time is on the x-axis, and it is. Time goes up to 10, and the displacement goes up to 20, and the y-axis goes up to 20. Great, yay me. Okay, I want to also show you how data isn't always this perfect. So I created this data table, 2, 4, 6, 8, 10, etc. And the numbers are perfect. I'm going to mess it up. I'm going to change this 8 to a 9. Okay, and I'm going to change this 16 to 13. Okay, and you can see now when you look at the dots right there, the plots of the data pairs, it's almost a straight line. And I've identified right here an outlier. Sometimes the outliers will be this obvious, sometimes they will be less obvious. But you know, you're not going to be dishonest and change your data. What you may choose to do is you may go back once you've discovered that at 8 seconds, that data point seems to be off. So you may redo that particular trial, remeasure it, and you may discover that, oh, you know, like I wrote down the wrong number or something like that. I measured it incorrectly. And then you can do the correction. So that's another reason why we would want to graph our data, because you don't always see the outliers in a data table. And certainly you're not going to see an outlier if you do only one trial. That's why we do multiple trials. So let me just leave those two outliers and continue. So the next thing we want to do is we want to go to the, I think we go into insert, do we? No. Okay, so the next thing what we want to do is we want to highlight the graph and double click the graph. And it'll give us a chart design menu. There you go, it jumps to the chart design. And I want to add elements. And the elements I want to add are going to be axis title, the chart title, and I also want to do a trend line. So that's where you find all of those things. So go back there, my axes title right here, primary horizontal, right there, double click that and change it. It's not being cooperative. Okay, and change that to time in seconds. Units are important. And then do the same thing for the vertical. And that's displacement. And that's in centimeters. And since the title, what they often do is they'll just take the y-axis, I don't know why it does this, and makes that the title. So I'm just going to alter the title. And I'm going to make this title descriptive. Okay, when you look at a graph, or when someone else looks at a graph that I've created, they need to understand what it represents. So I need to pick a title so this makes sense to you. And I'm going to say that this is the motion of an ant across a hot sidewalk. How about that? Okay, so that gives you an idea what the experiment was all about. The last couple of things we need to do is we need to add a trend line. So I can do here, and I can pick different trend lines. I see that this is linear, so I'm just going to pick linear. There's more options here, so if it was exponential, I could go there. But let's just do linear for now. And that gives me the best, what's called the best eyeball fit. So if I was to draw this on a piece of paper, I would use a ruler, and I would do a best eyeball fit. Excel actually calculates the best trend line. And we want to locate that calculation. And the way we do that is we click on, say, one of the data points right there. And I don't know if you can tell, but the trend line was actually highlighted. There's a little light blue circle here and a light blue circle here. And I'm going to right-click now. And I'm going to format the trend line. And when I format, you can see I can change it to exponential, logarithmic, etc. And let me show you where that is. At the bottom here at the page, I can have display equation on the chart and R squared value. And those are the last components. The equation is very important because it will identify the slope of the line. And we know the slope of a displacement time graph is the velocity. So it looks like the data I have here, the velocity of the ant, is on average 1.9091 centimeters per second. And we know our data is pretty good. I can see our data is pretty good because most of the dots touch the line. But the R-square value actually numerically tells us that it's very good. We want an R-square value as close to 1.00. If you did an experiment and you reported an R-square value of 1.00, I would probably start laughing because no one can create an experiment that perfect. The universe doesn't work that way. There's all kinds of things that interfere. But if you had data like this, I would say, yeah, that's what I would expect. Most of it is good, and there are a couple of outliers. Now let's see what happens if I go back to the table and I say, oh, there's that outlier 13, and I remeasure it, and I find out that it's not 15. Indeed, it's actually 15. So still not perfect, but it's better. And what it does is it adjusts it, and you see that the slope of the line was altered, and you see that the R-square value is actually better than it was before. Okay, so that's how you create a graph and a data table. And when you're done your homework assignment, I just want you to screenshot and upload the screenshot of your work to your Google Doc. Okay, so let me shut